Hello and welcome to today's lesson where we shall be treating integration by method of substitution. Suppose we wish to integrate integral u of x v of x dx and the second integral is integral u of x raised to the power n vx. Once we notice that the derivative of u of x is v of x, in this second case, we also notice that the derivative of u of x is v of x. Then this method can be applied. What are we saying in essence? Once we notice that the derivative of one of these functions is the other function, then this method can be applied. Let us take an example to clarify what we are really saying. Let's evaluate the integral cos x sin x dx. In this integral, our u of x is cos x and our v of x is sin x. Or you can call sin x your u of x and cos x your v of x. How do we know if we have to apply this method or not? Observe the following. We observe that if we differentiate sin x, what do we get? Cos x. That is all you need to identify in a particular integral to apply this method. We observe once again that if we differentiate sin x, we get cos x, and that is all we need. So once that has happened, we now say let u equal to what? Sin x. Or to do that, to differentiate, du over dx gives us what? Cos x. We now make du the subject of the equation, so that becomes du equal to cos x dx. We go back to our integral. Our integral was integral of cos x sin x dx, which you can also write as sin x cos x dx. And this integral becomes the integral of what is sin x? Our sin x is now u. What is cos x dx? Our cos x dx is du. The integral now becomes the integral of u with respect to u, which we can easily integrate. If we integrate u du, what do we get? We get u squared over 2 plus our constant of integration c. But what is u? U is sin x. So we now write this as sin x all squared divided by 2 plus c, which can be written as sin squared x over 2 plus c. And we are done with the integral. So what we observed was that when we differentiate sin x, we get cos x. And that was all we needed. We take the second problem. Here we have the integral of sin cube x cos x dx. We're asked to integrate. We watch again closely. If I differentiate, now let's rewrite this first. We can rewrite this as the integral of sin x raised to the power 3 cos x dx. So that if we do it this way, the integral is now in the form ux raised to the power n vx dx. So we observe that if we differentiate sin x, we get cos x. Once we have identified that, we can proceed with the method of u-substitution. So we say let u be what? Sin x again. Let u be sin x. And once you have said that, you differentiate du with respect to x. And that gives us what? Cos x. Like we did before, you now make du the subject of the equation, so that du becomes cos x with respect to x. So our integral, which is sin x all cubed cos x dx, now becomes what? The integral. Sin x is now u. That becomes u raised to the power 3 cos x dx. Cos x dx is now du. So we now have the integral of u cubed du to integrate, which is now an easier task to perform. So if you integrate u cubed, you get u raised to the power 4 over 4 plus our constant c of integration. What is our u? Our u is sine x. So if we replace u with sine x, we simply have sine x raised to the power 4 divided by what? 4 plus c, the constant of integration, which you can also express, if we want, as sine raised to the power 4 x over 4 plus c, our constant of integration. Let's take another example to further clarify ourselves. Here we are asked to evaluate the integral of cos x squared times 2x with respect to x. Now this integral is not in the exact form as the last two integrals we've performed. However, we can still apply the method of u-substitution. What do we observe? We observe very quickly that if we differentiate the function inside x squared, what do we get? We get 2x. Once you identify this factor, proceed with the method of what? U-substitution. So we say, let u again be what? X squared. Because if you differentiate x squared, you get 2x. So if u is x squared, du over dx gives us what? 2x. We now make the u the subject of the equation, so that du becomes 2x dx. Now the integral we were given, which was the integral of cos x squared 2x dx, now becomes the integral of cos x squared is now u, cos u, 2x dx is now du, So we now have the integral of cos u du to integrate, which is a lot more easier. So if we integrate cos u, what do we get? We get sine u plus our constant c of integration. But what is u? U is x squared. So to replace u with x squared, we have the sine of x squared plus our constant c of integration. Let us take the last example. We are asked to evaluate here sine into x squared 6x dx. And this problem looks, similar to the last example. But let us see if we can apply the method of u-substitution. So we will differentiate this function inside x squared. What do we get? We get 2x. And this is 6x. So it looks as though that method cannot be applied. But it can be applied if we tweak the problem a little, as follows. We can write this integral of sine x squared 6x dx as what we need here is 2x, not 6x. So I can write this integral as the integral of sine x squared. I can write this as 2x dx as long as I write 3 outside. Since 3 times 2x is 6x. So I've put this integral in the form where I can apply the method of u-substitution. Since 3 times 2x is nothing but 6x. Why have I done this? I've done this because if I differentiate x squared, I get 2x. And for me to proceed with the method we are discussing currently, I need to have this function as the derivative of this guy. So with this, I can proceed. I say let u be what? X squared. So that du over dx is what? 2x. And I'll make du the subject of the equation. I get du equal 2x dx. So my integral now, which is 3 integral of sine x squared 2x dx, now becomes 3 integral sine, what is my x squared? My x squared is u, sine u 2x dx. My 2x dx is now what? Du, is now du. So I now have 3 times the integral of sine u du to evaluate, which is a lot more easier than the original integral. This gives me 3. When I integrate sine u, what do we get? Minus cos u plus our constant c of integration. But the original problem had no u. We said let u be x squared. So this becomes minus 3 cos x squared plus c. As an exercise for you, evaluate the integral of cos cube x sin x dx and leave your answers in the comment section below. Bye for now.